So we're looking at similar. What do we know about similar figures besides they're similar, which is what I hear every single hour? What do we know? Warren? Same shape. Yeah, they are the same shape. Okay, what else? Same angle measures, right? That's what makes it the same shape, is that they have the same angle measures. So what we say about similar figures is they are the same shape, not necessarily the same size. All right, that's our definition of similar figures. Same shape, not necessarily the same size. What we're talking about today are the basics of similar figures. And then later on in the chapter, we get to how do we kind of prove that they are similar and kind of that stuff. We don't actually see proofs, but we talk about theorems a little bit different. So we're looking at the same shape, not necessarily the same size. So you see it here, we're talking about corresponding parts here. And the corresponding angles are congruent. We said that, and we can see it. But the sides are not congruent, right? The sides are not congruent. What we would say is that the sides are proportional, okay? Corresponding sides are proportional. So let's write this last sentence down. Corresponding side lengths are proportional. By the way, the theorems that you already have written down, those come in on the second half of 8.1. So we're not even going to look at those today. So anything that you want down from today, you're going to have to write down as we go. Okay? So corresponding side lengths are proportional. And we know that angles are congruent. So those are the two things we know for sure about similar figures. I want to put one more thing down there for sure. And I want you to make a note that sides are not similar. I see this every year during an explanation on a quiz or a test, or I guess the test, when they're giving an explanation of why these are similar figures, and they go, well, the sides are similar. Sides cannot be similar, okay? Figures can be similar, triangles can be similar, pentagons can be similar. Sides cannot be similar. Sides are proportional, okay? There's a big difference in the word, so please use the right one. Side lengths are proportional. They are not similar. Okay, so get that in your mind. Make sure that you have it down so that when you study it, you remind yourself, do not tell me that sides are similar. That's not a thing. So instead, what we know are that the sides are proportional. Backtrack a little bit. When did we talk about similar figures already this year? Anybody remember? Aiden?
Chapter 4.
Chapter 4. We see it up there, 4.6 with similarity transformations. What made them similar figures? Dilations, right? So we were dealing with dilations. That's where we originally came up with these similar figures. So that same idea, those same ideas as dilations still stand here, which means we have a scale factor, right? Scale factor is how many times bigger or smaller it is. So we still have this idea of scale factor, which by the way, is represented by the letter K, if you've forgotten. K stands for scale factor. And it's also in our paragraph up here. So we have the fact that these sides are proportional. And a proportion, if you remember, it's been a while since we actually talked about proportions. A proportion is when two or more ratios are equal to each other. And our ratios are just the two side lengths, the two corresponding side lengths, put one on top of the other. So like DE and AB. DE and AB are corresponding side lengths. Those side lengths match up. So we put one over the other to get that fraction. We do the same thing here and here to get that fraction. You've seen problems like this before, right? You'll see them again today. If that's 3 and 5, then this would be 9 and 15. Being able to say, all right, 9 over 3 is equal to 15 over 5. Okay, that's what we mean by proportional, is that those fractions are going to be equal to each other. Okay. The last couple examples that we'll look at will be solving for x, right? Like we've done before, where we know 3 of the sides. We want to find the 4th side. We'll plug in x and do what we do. But before that, we got to get all these basic intro stuff out of it. All right, questions so far on our similar figures, proportional sides, congruent angles. Okay. Couple things to point out here. This is a similarity statement. We've had congruency statements before, right? Congruency statement said this triangle is congruent to that triangle. Now we're dealing with similarity statements. So that symbol, that one squiggle, that is the similar sign. So that's saying this triangle is similar to this triangle. It's not the same thing as congruent. It's a different symbol. So we got to make sure we have the difference down on that and we use that for symbol. Just like a congruency statement though, the letters match up. So I can look at that similarity statement without even looking at the picture. And I know for sure that angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Just by looking at that similarity statement. I also know that I could set up proportions with my corresponding sides. I know AB over DE would be equal to BC over EF. Right? So I can create that proportion as well. All based on that similarity statement. Okay, questions on the similarity statement? All right. Down here, when we have all three of these fractions put together, this is what we call a statement of proportionality. And they are going to ask you to create this. So it's important that we understand what that looks like. So please put it down. Even if you don't have the figures, write this down so we know what it looks like when we get there. This is a statement of proportionality. Statement of proportionality. Notice that the statement of proportionality is all three pairs of your corresponding sides. So it's three fractions set equal to each other. And it uses the names of the sides. It doesn't use numbers. It uses the names. Okay, so even if they did give us numbers on these figures, the statement of proportionality would simply be the names of the sides. All right. Good. Any questions on our intro vocab sort of stuff here? Okay. Okay, tell the person next to you three things about similar figures. All right, so the first few questions that you see in the homework are going to look like this. And they're going to take a little bit longer just because they got multiple parts and all that. So they're telling us that we have similar figures. They give us a similarity statement. And then they're going to ask us for a few things. B is the easiest out of all these, right? List the pair of congruent angles, piece of cake, we know that, right? R and X, S and Y, T and Z. We can do that just by the similarity statement. Now for A, we talk about scale factor. Scale factor, right, is what do we have to multiply by to get to the next triangle. The important thing to remember here is it matters the order that you put these things in. because it tells us we're going from RST to XYZ. We're going from the bigger one to the smaller one. We're going from a big triangle to a small triangle. Is my scale factor going to be bigger than 1 or smaller than 1? Smaller than 1, right? Because we're getting smaller as we go. So that means that XYZ has to be on top of that fraction. Okay, if you recall back on when we talked about dilations, when we talked about scale factor, we always said scale factor was image over pre-image. That still applies. The pre-image is the original one. The image is the new one. So the original one from RST means my number from RST is going on the bottom. My number for XYZ goes on the top. All right, image over pre-image. If you want to write new over original, or however you want to think about it. Wherever we're starting from needs to go on the bottom. Wherever we're headed to needs to go on the top. Otherwise, you're going to get the reciprocal and you're going to get it wrong and you're going to wonder why it's wrong. Why don't you go ahead and find the scale factor from RST to XYZ, please, if you haven't already yet. If you have, give other people a chance to look at it.
Yeah.
You said it has like 1, right?
Oh, yeah.
Gotta be careful.
Oh, because images. Oh,
Image is the
yeah.
new one, right? Where we're headed. Okay, here we go. Regina, what is my scale factor going to end up being here? 0.6 or 3/5. Okay.
You think it's acceptable?
They should accept both. Yep. Sometimes it's going to be easier just to write the fraction, right? If it's a repeated decimal or something like that, but they should accept it. 3/5, that would be 12 over 20, simplified. There you go. Good. Questions on that scale factor? It's very important that you remember which order. Okay, that's really the toughest thing there is to know which one goes on top, which one goes on bottom. Now on C, it's asking for that statement of proportionality. Okay, statement of proportionality. Talk person next to you. What's that statement of proportionality going to look like?
RT is
RT over XC XTS over Y equals YX over XY equals
We don't need the equals paper. Just the 3. Just the 3 fraction.
Wait, do we have to set up like the image over pre-image, the ratio?
We don't have to for this. Typically we do, but you don't have to. Right? The only time you have to do that image over pre-image is when they're specifically talking about scale factor. All right. So our statement of proportionality, remember, is not the side lengths, it's the side names. Right? So it would look something like this. Okay. And notice that we do not have equals K. We don't need that equal to the scale factor for our statement of proportionality. We just need our 3 fractions right there. And as I was telling Braylon, we don't need to do it pre-image over image. We typically do. Well, the only time it's a necessity that we do pre-image or image over pre-image is when we're talking about the scale factor. Okay. If we're not specifically talking scale factor, then it doesn't necessarily matter which one goes on top. Okay. All right, so let's move on from there. Okay, now we get into the types of problems that we've seen before. Okay, we've seen stuff like this before. You got 5 out of the 6 side lengths. We're asked to find the 6th one. There are lots of different ways that we can go about solving this. I want you to figure out what X is going to be, however you see fit. And then we're going to talk about a couple different ways that we can do it. Feel free to talk to somebody about it. So, what are you going to do?
Yeah, which one's the image?
Doesn't matter. Because they're not asking for a scale factor as an answer, it doesn't matter. If you haven't yet, check somebody, make sure they have the same answer as you. You know, that is if you have an answer. If you're just relying on somebody else, then I guess get the answer from somebody. Would you cross me? Yeah, if you can. There's other ways you can do it, but that's gonna work for sure.
I also kind of just noticed there's like 3 little surprise occurrences. They're like,
Well, that's not always.
I know.
No, but it's really good that you saw that for chapter 9. Yeah, that's a good. Just gonna help you in testing. All right. So what did you do to get our answer here? Tim, what'd you do? Okay, so we had 25 there. And so she found the scale factor and then used the scale factor, right? 15 over 18, got that scale factor, or 18 over 15, and then divide it. That works. You can do 15 over 18, get the 5/6, and then multiply it. Either way, that's going to work, right? That's probably how a lot of you did it, which is perfectly fine. Okay, the problem with that is we can't do it all the time. Because once this side becomes 2x minus 4, now that becomes a little bit harder to do. And this is where the proportions from the warm-up come in. Okay, so what we can do every single time, guaranteed to work, guaranteed to set us up right, is set up that proportion. All right, I would do corresponding sides here. So 2x minus 4 over 30, and then find another pair, 15 over 18. Right, set up that proportion, and then we can cross multiply like we talked about in the warm-up, where you're distributing the 18, you multiply those together, and you get an answer. Okay, this is guaranteed to work every single time. Just like in the warm-up, where we said, all right, the first 2 we can use kind of the shortcut, but the last 2 we have to do this cross multiplying. It's that same idea. Okay, so use whatever method you want, but when nothing else is going to work for you, set up the proportion cross multiply. Okay. Last thing that I got to point out, it's not just side lengths that these work on. Okay, it also works on altitudes. So inside the figure, it works on altitudes. I can put an x here and solve for x. Doing 12 over 16 x over 20. All right, it works for altitudes. It also works for medians. If you recall, medians connect the vertex to the opposite midpoint. So same thing, I could solve for Km here, x over 35 is equal to 48 over 40. So it's not just side lengths, it's those other ones inside that this works for. Okay. Any questions?